Hello everyone, it is me again, February 17th today. Before we started today, I was reading about the new PEP 634, 635, and 636. It's a new feature that's going to be added to Python 3.10. Very exciting news for me because the new feature is the pattern matching. Now, pattern matching, I encountered pattern matching when I was learning Scala. Apparently, this is something of the functional programming language. They do this pattern matching, and it's very useful. You just you have a variable that you want to match it to one of the targets that you want, and then using pattern matching, it's similar, I would say, to the switch statement in C, but it's more powerful because in switch statements, either C or C++, JavaScript, whatnot. A switch statement only does a comparison, a direct comparison, equal comparison. But with pattern matching, it's not just about the value comparison, but also about the pattern. Is we can match the shape of a list, match an object based on the attributes and all that. Now, what interests me more is I start reading into it, and there are apparently two camps of this. One camp is in favor, like me, very much in favor. I think it's going to be very useful. It can reduce a lot of if else and if else, those ways to write pattern to write this type of match. I mean, it's doable in Python right now. You just have to write a lot of if statements, and I definitely don't like. I think it looks ugly, and pattern matching is very intuitive the way that it's designed. You guys can read. I think it's the 630. Let's say 636. I think it's the PEP 636 is the tutorial. Very well written tutorial on how pattern matching syntax works. However, on the other camp, there are people who argue against it. They say this is not Pythonic. This is basically just Python wants to cash in on the current trend, which is not a current trend, but pattern matching is a big part of functional programming languages, and Python has incorporated part of it, like the map, the reduce, the filter, but it never really goes to the pattern matching. So they try to do that, and then other people say it's because Rust has it. Now Rust is the starting language right now, and then Rust has it, so Python wants to have it. And also the argument is in the Zen of Python, they say it should be preferably only one obvious way to do things. And given that pattern matching was not included, it seems it's not that difficult to implement. And it kind of begs the question, why is pattern matching not included in Python when it first started? My guess is when it first started, Guido probably just think, well, why do we need pattern matching where we can do the same job with if and else? We can do if and else, and technically speaking, the amount of lines saved is not that much. And people also raise the issue of readability. I mean, definitely if and else might seem more readable compared to a pattern matching. So that's one thing. Like if you haven't implemented back then when Python first started, why do you want to do it now? There's got to be a reason why you don't why Python didn't include pattern matching back when it first started, and to include it now seems to be going against the Zen or the design principles of Python. Now that's one opposition voice, and the other opposition voice is Python is just trying to add too much. It's starting to turn into C++, and we all know why C++ fails, because C++ wants to be everything, wants to add everything, and then just getting bloated and bloated. And Python seems to be going down that path as well. Just keep adding more features, and then kind of not really asking whether this feature fits the Python spirit. But for that argument, I'm not quite sure, because I don't even know what Pythonic is, right? It's a general language right now, and trying to be as simple for people to use. And for me, adding pattern matching is definitely a plus. It's something good, right? It's make people's life easier for me at least. And the final argument against pattern matching is about a typing system. Now, pattern matching with a strong typing system, like all those functional programming language, they have very strong typing, even algebraic typing. So with those typing systems, it's easy, very easy to do pattern matching. It doesn't really require extra thought because you pattern match based on type. Now in Python, typing is not strictly enforced. However, over the past few years, the type hints and has been more and more welcome by developers because we see the benefit of including types. Um, so apparently Python cannot use typing to do pattern matching. So there could be a little bit of performance issues with pattern matching. But at the end of the day, I think pattern matching is a good addition, and I support it until right now, and I'll see how it goes when I actually start using it. But it's pretty sure that it's going to come out in 3.10, so the end of the year, most likely, it's going to come out. So once it comes out, then let's just give it a shot and see how it works. All right, that's about what I want to say now, and let's go into the challenge for today. The challenge for today is going to be, is this my solution? No, it's not my solution. The challenge for today is going to be reveal container with most water. Huh. Oh, I've done this before. I think this is exactly the same I did many times. I think I at least did this 2 times on my own, and one time, the interview was not container with most water, and there was the interview was something different. I did this before. Yeah, definitely. All right, let's just read again. So negative integers and points at coordinate. Okay. And then we have unvertical lines, so such that the 2 endpoints of the line is at I, okay, and I is 0. And the line is I, A, and I 0. Find 2 lines which together with the x-axis forming the container such that the container contains the most water. We cannot select. Alright, so basically it's just, you have all these, you try to find 2 vertical lines that can hold the most water. I remember I did it with a very convoluted way, and then the solution is really, really brilliant. I'm trying to think. I remember the solution is going from both sides. That's the only thing I remember right now. It's like going from both sides. But I don't remember how that one is implemented. But given this type of question, I think the stack is usually how you use it. You want to create a strictly increasing, non-decreasing. How should I put it? All right, let's just give it a thought. Let's not think about going from both sides because I kind of forgot how that one works. Now let's just go from stack. So apparently, you start from 1 and you have 8, and then they're not gonna hold any water. So they can actually hold water. So do I calculate the amount of water you can hold immediately? And they can hold only this amount of water. And then we add this, and then they can hold in this amount of water. What are we trying to do? What are we trying to do? What we're trying to do is to find, What are you trying to find? Hold on. So we also don't care about this, right? So it's 1, and this is 7. 1, 2, 3, 4, 5, 6, 7, 8. It's 7 in between. 7 times 7. Yeah. So it doesn't really matter of this. So basically, we need to find the largest of the distance times the height, right? This distance times the smaller of the height. So which approach do you want to go? I want to go with the stack approach. Let's see if we can solve it. For the stack approach, I will say that the most we can hold. Huh. So like when this happens, do we pop it out and just see how much we can hold right now? So every time we encounter something that's bigger, we're gonna pop it out and then replace with this and then compute how much water we can hold there. And then we here, I'll pop it out and how much water we can hold here. Is that what you're trying to do? No, apparently not. Yeah, that's different. That's different. And those has nothing in between. We're trying to hold like this thing, and this is different. You can hold water here. I think it's not like that. Let me think. So if we start from both sides, right, both ends, and then so the end result must be some eliminated, some parts, and then we compute the things in between. That's the end result. And we know. So we start from both ends, and then we can just come in and see if we can find a bigger one. So like here and here, we know it's going to be like this. I would have a value, and then we move this in, and then we have a larger value. So whenever we have a larger, I think I'm getting it. Whenever I have, so we can move any, we move the small side because I have a small, I have a large. If we move the large, it's not gonna, if we move the large, it's not gonna help us because it's determined by the small. So if we have a small and we have a value, if we want to make more, what we need is to find a bigger one, right? A bigger one. So we move the bigger one, and then we compute. And then now this one is bigger. This one is bigger. So in order to have even more water, right, than what we have right now, because we already have this option, and we know this option is bigger than this option because we move from the small, we move in, we try to see if we can find a bigger one, because if this one is smaller, then that's definitely smaller than previous. But if this one's bigger, then it will be bigger than previous. So we move in, and then now we find out this is bigger, so we have this volume, and then we see this is big and this is small, right? Which means in order to get even more water, what we need to do is to find an edge that's higher than this, right? Because if we find some higher than this, it's not going to work. Lower than this, at most, is the same, right? So we're going to find something higher than this. So in order to be higher than this, we need to move in. Now we move in and find it's actually smaller, so we don't consider. Move in, this one's higher, and then we can compute a new value, and then it's not. Um, what if it's the same? How do we move? If these two are the same, 8 and 8. When it's the same, do we just randomly move on either side? It doesn't matter. Huh, if it's the same, we move on one, do we have to move on the other one as well? If we have 2 is the same, and we want to keep going, how do we move? Because if we move on one side, if it's smaller, then that's a move point. If it's smaller, these are more movable points. So it only matters if there is something bigger, right? If there is something bigger in it. If I move, say we have something bigger here, and I move here, then I get a result. But if I move here, okay, we have to move it twice, right? Is that what it's saying? We have to move twice. But then we created an issue where we create an issue. I mean, we're gonna move until we find a big one, right? And then if they're the same, so we're gonna move until we find a big one, and then how do we resolve this issue? We're gonna find a big one, and then because it's the same, right? So both sides are the same, and I'll find a big one, and then it will be, hold on, if we have 2 other things, right, and 2 other things, and we go in and find a big one, then the big one is not going to make any difference because these 2 are the same, or it's filled it, right? Or it's filled it. So anything in between is not going to make a difference because they are the highest, right? So the only difference it's going to make is if we have 2 large ones in the middle. There's only one large one, doesn't really matter. So we move on both sides until we find a big one. Yeah, so yeah, that's how we do. We move both sides until we find a big one. Yep, I think that's the solution. That's the one, because I do remember that you have to go from both sides in. So, all right, let me get one more thought. Yeah, I think it's good. I think it's good to go. Good to go. All right, let's do this. Copy it. Ping. Ping. All right. Let's see. Put it here. Yeah, we most likely don't need the deck. All right. Area. We've done this before. So we just need 2 pointers. Left, right equals 0 and len height minus 1. Right? And then left equals 0. And then while left is smaller than right, And we're going to compute. We're going to compute what? Compute. So current. So rest equals max rest, and it's going to be right minus left. That's the number of it's the number of it's the number of the width of the tank, the width of the tank. 1, 2, 3, 4, 5, 6, 7. Yeah, width of the tank. So it's the width of the tank multiplied by the smaller of the height. So we're gonna go smaller height left or height right. So we do this, and after we do this, we're gonna move. Right? We say if height left is smaller than height right, then we move until we find one that is higher. Can we do this? Like it should be like smaller or equal, right? We have to do it equal, and then we just say while height, height has to be smaller than this. So we're gonna say as height. Then we say current left height equals height left. Or I'm gonna call it here. Left h, right h equals height left height right. And then we don't have to do height left height right. Because we say left h here is going to be right h. And then I don't have to do this. I can do left h right h. Then we say while left is smaller or equal to left h, then left plus equals 1. If the left is smaller or equal to my current left, we're going to move smaller or equal, we're going to move until we find one that is bigger. Then we stop. And we do the same thing on the right. So we're going to say if left is larger or equal to, right? And then when we say while right is smaller or equal to right, then we move to right minus equal 1. Right? And what if they cross? That's fine, right? If there's only one, and then the left and right they cross, then that means that one doesn't really have any effect. It only matters if there are two. If there's only one bigger, then that's not going to have an effect. So once we're done, do it again, and then we're going to return red. And then we are going to check the result. So the first one is supposed to be 49. The first one is supposed to be 49. Second one is 1, 1. Supposed to be 1. Third test case is 4, 3, 2, 1, 4. Supposed to be 16. Last case is 1, 2, 1. Supposed to be 2. And I want to add another one, which I think will help. That's actually fine. I think it's fine. These shall be good enough. And we're going to do height here. Change this into max area. Height. Index out of range. Huh. Index out of range. Of course, because we keep going, so which means if the left is continuously being smaller than the right, which one is actually causing this? Ah, this one is causing this. So while left is smaller than land height, and so we will only, wait, left will end up like, yeah, that's fine. And then this one as well. And the right has to be larger or equal to 0. Now we pass all of them, and we have a lot of issue here. Yeah, this is always annoying. Alright, let's try put it in. And we don't have to run any test case, we just submit it. And we are through. I think this is exactly the same method I used last time. And yeah, this is the official solution. Most likely, this is the official solution, as I have done this problem before. I've done this problem before. I probably should also record like which question it is, so in the future when I go back to these, I know immediately which question I did. Huh. Anyway, I think it doesn't really matter. We can always go to the explore page to see which one you did. Yeah, explore page I think is good enough for us to know which one we have done. So we open this, it tells you, oh, it doesn't really give you a date. So you kind of have to calculate, like 15, 16, 17. Anyway, so I say if I'm done 4, I've done this problem before. It was a tough one for me back then, and I remembered that the solution involved 2 pointers moving in opposite directions. I was able to figure out how the pointers move. Call points move this time without too much trouble. Basically, we start from both ends and move the pointer with a smaller height. Move the pointer with a smaller height towards the center until a bigger height is encountered. This works because only bigger height is possible to yield a larger area compared to the starting state. The slightly tricky part is when both pointers are at the same height. In this case, we need to move both pointers because move both pointers because any moving one doesn't really matter, because the only chance, the only possibility that a higher area, a higher area will be found is when there are two heights in between that are larger. Thus, we have to move both pointers. Alright, this is ON. Everything only goes once, and I had 172 milliseconds, which is at 52% ranking. Yeah, I'm pretty sure that the actual solution probably is also similar to when I wrote it last time. Anyway, I passed this. This one has solution. I think this is a medium one. Oh, maybe it's a difficult one. It's a medium one. The medium one. Yeah, it was a long time. Oh, it's 11. That's why. Oh, I think I'd like to start from now on. I'm gonna label it LeetCode 11. Yeah, it's a classic one. Very classic. Solution. Let's see. Brute force is going to time out every possible pair. I'm not sure. Is it brute force timeout? What's the 10 to the 4? Yeah, brute force is no timeout. No question about it. Two-pointer approach. The area formed between the lines will always be limited by the height of the shorter line. That's true. The farther the lines, then more will be the area obtained. Yes. Take 2 pointers, one at the beginning and one at the end. We're making a variable max area. This is the maximum area obtained to now. And if that we find out the area formed between them. Update max area and then move the pointer the shorter line towards the other end. That one step. I think it's only like move one step at a time. Oh, it only move one step at a time. So like smaller will move one step, I compute. And smaller move one step, and we compute. And if it's the same, I think it's just move both. Move both. So move one at a time. So it's even simpler than my implementation. I will keep moving until we find a big one. It's the same idea. Same idea. Exactly the same idea. But it's yeah, simpler to write it that way. Alright. About this cryotape. This was posted a long time ago. Simple proof. Yeah, it works. I think I did it a long time ago. Yeah, back when Hawkman was still active. And we hide a smaller one. All other containers are less wide unless we need a higher water level. We want to hold more water. That's true. Smaller one at first and last line doesn't support a higher water level and can thus be safely removed for the consideration. Yeah. Oh, back then he wrote a lot of explanations. Neither smaller. Yeah, just move both. They just move both. Yeah, people will complain. Oh, I never upvote him. I never upvote him. Get him more upvote. Oh, he posted the same thing twice? Man. Oh. Alright, let's go to our submission. Let's see when I first started. Oh, wow, look at this. Look at this. What is this? I use Python. What? There's a 56 millisecond solution? What the hell? I hit a 60. Okay, but back then, let me see. That's August 15th, 2018. That's the first time I did it. I encountered a time limit. I think that was probably very common. We don't even want to see it. And I did, after an hour, almost an hour, I got accepted. Let's see. And then I got accepted. And I wrote in C. And I encountered it again. Yeah, this is the third time. So in August I did it, and then in December, why did I do it in December? I don't even remember why I did it in December. Oh wow, look at this. This is exactly the same as my current one. Yes. So over the time, nothing has changed. Or things have changed a little bit. I have a better expression for this. I do. Yeah. Yep. So 2 years and 6 months ago, the test case must have changed. Yeah, back then it was only 50 test cases. Oh, this is a good example to show you guys that this thing is not really reliable because the test case can change. So back then there were only 50 test cases. Now it's 50 test cases. Oh my goodness, what was this? A list for height positions. Oh, height positions. Oh, ooh. Yeah, I don't want to read this anymore. So like back then it's 50 test cases. And let's also see here how many test cases there are. 50 test cases. And that's December. That's December 2012. And 2018. Now look at 2021. We have 56 test cases. So we increased the test case by 6. And the runtime is increased tremendously. So it's another way to say that it's not really reliable because it's all the data. All the data are aggregated together. This data at this time. That's what I think. I actually don't know. You know what? I shouldn't even speak. No, I don't think it's aggregated because back then I have the solution and it didn't show me anything. Right? Didn't show me on here. That means I think every time they change test case, they probably have to redo this, or at least like scale it. That's an interesting question. So just for LeetCode. Anyway, well, this is the question we've done many times, and I'm pretty happy that we got it right first time. This time, that shows improvement. All right, that's it for today. We're doing good. I will see you guys tomorrow for tomorrow's challenge. Adios.